5 years. One of the things that I used to do is I used to do incident response. I still do incident response. And some of the other things I do are listed up there, but one of the key things is I've actually run B-Sides London. So if you've ever been to B-Sides London, it's like, thank you for coming. This is a long way to come. Basically, what I'm introduced to today is, it's about the endpoint. I've always been a big proponent of the endpoint as a solution to do defense and to do incident response, but also to actually be able to, I say, get more information. We've had a tendency of, in the past, we've had a tendency to focus on the exterior, right? A number of years ago, you probably all remember this, there was the defense in depth model. We kind of dropped the defense in depth model. People started losing faith in the endpoint technologies that we were actually deploying. So the circle became big on the outside. We started, we kept protecting the perimeter, and we lost track of the inside. And the problem is that if you think about the attackers, the outside is just the wall. It's just something to bypass. What they're interested in is the inside. It's what's at the core of your information systems. It's the critical assets that the users are using, that people are using, anything that's just basically sitting on a machine, whether it's a server or whether it's a laptop or whether it's a desktop. My paradigm is this, right? So, do you guys all know the Maginot Line? Remember the Maginot Line? Okay, the Maginot Line, the French. So I'm French, so I can basically say the French had an interesting idea. But as usual, they never finished it. So basically, by the time they actually got to it, they built it, it was outdated technology, Germans just ran over it. But this isn't the first example. If you think about it, the first example of a wall to keep that you can think of. So do you guys know what this one is? So that's Hadrian's Wall. The Romans built that between Scotland and England. And the funny thing is, most people think, well, it's a defensive wall. It wasn't. It was a status symbol. And that's what, for me, a lot of our perimeter defense technologies have become. They become status symbols. It's like, I've put Palo Alto, I've put all this next-gen firewall technology in front of my perimeter. The problem is the perimeter doesn't exist. And the funny thing is with Hadrian's Wall is that when you think about it, when they built it as a status symbol. It didn't keep the Scots out. Right? The Scots still came into the Roman Empire. It had the adverse effect. The Scots came in, they reaped and pillaged inside England, but they couldn't go back. Because, in those days, you reap and pillage, you've got all these big carriages full of stuff, you can't get it over the wall without going through the gate. So instead of actually stopping people from coming in, they stopped them from going out. And to a certain extent, we're not doing that today in information security with our perimeter technology, but we have that same thing. Is people are getting in and they're sitting and residing in the endpoints, they're sitting and residing internally. This is one of my favorite things. Is walls lost their effectiveness in 1545, and if you think about 1545, that's when Marco Polo actually brought gunpowder to Europe. So, are we in the wrong place? So we're relying a lot today on what they call next generation network technology. You've got sandboxing technology, you've got this. The endpoint solutions that we're seeing on the market today, they're built for the incident response type perspective. They're more built about after the incident, right? They're built about creating your forensics image, getting your forensics information. And we look at suspicious logs. We look at we look for things that are active in point resolution to decide what's going on. And we kind of look at what's changed, but we're actually not looking at what happened, right? So when we're trying to get to understand how our environment was compromised, we're basically looking at a snapshot in time, and we're trying to go back and build a timeline and say, okay, this happened, plus this happened, I think this happened, I'm not sure, but I think this happened, and I think this is how they got in. And there's some downfalls to that. So the endpoint can actually provide a world of information, right? So if you've ever done any basic research on the endpoint, if you've ever done troubleshooting on an endpoint, this is Windows example. You've got tools, and I mean in the Windows world, I'll focus on the Windows world for this. But basically, if you go to sysinternals, there's some really nice tools. This is TCP view, so you can see every active process, every active network connection that's going on, including the remote address, the local ports, the local address, IP addresses. You can get sent and received by the states of the connections. Then you've got Process Explorer. Process Explorer is a really nice tool. Process Explorer, unlike the Task Manager, will actually give you a lot more details about what the process is doing and how in the hierarchy of processes. So this is a snapshot. This is actually a snapshot of dried eggs being run off a compromised Excel file. And you can start drilling down. So drill downs don't reflect what's in the first picture. So you can start to see information. You can see things like command lines, where it's running from, what the user is. That can be important because you can see that it's not a normal user, it can be an admin user. You can get things like what kind of threads are running, what DLLs have been loaded, and you can do things inside the process. So a world of information. But this is my favorite tool. So this is Procmon. Procmon is very noisy. And this is one of the problems with when you're looking at endpoint and looking at detecting what's going on in real time on an endpoint, you start to generate a lot of noise. So this is just a snapshot of Explorer and everything that Explorer is doing when you're basically opening windows in Explorer. So you can see it's like creating a file map, it's loading an image, it's closing a file, it's reading a file, it's creating a registry, and it carries on. It might create a network if you're actually doing some, if you've got remote shares open, if you're connected to a network share. So it's doing all this, but the interesting thing is it's giving you a lot of information. It's giving you like the time, the process, the PID. You can actually drill down into that and actually get to the parent processes involved, the operation, you've got a path, whether it was successful or not, and then you can get some more details of why it was successful, what was going on there. So all this is information that when you apply to actually looking for incidents or actually looking for how machines being compromised, if we had this kind of information, we'd actually be able to see the real timeline of how, for example, Excel was broken, or how the drive-by happened, what was going on when the drive-by occurred. So with this information, we start to build an application DNA. So we can start to group events together, and we can track a number of events and say, well, if I see multiple file writes and reads in the sequence, I can basically say that the user or the application is editing this file. So you can create a file edit event. Or if I see things like a file being renamed from one directory to another, I can say, well, this is a file move operation. So you start to give more context to the events that are happening. So, well, what I'd like is to have all this in a single, basically, intelligent endpoint agent. And that's what we're starting to see come on the market. One of the things that we're seeing is there's a number of companies, including the one I work for, where we're deploying, you start to see deploying of agents at the endpoints that are collecting all this data and reporting it back. Now, the problem is we start to get a high level of visibility. So you can start to get all the file operations, all the network operations, the registry operations, the process data. Some endpoint agents will actually keep that memory and give you just raise alerts and give you a map of the events that happened in the sequence. And they'll do that in the sandbox so they can control what's going on. But overall, what you're interested in is the information that you can provide. Because not every solution, not everything that you see, or everything that happens can be related back to something that's known. And it's the unknown unknowns that you want to look for. So this is very small, but I'll show you some more details of some of these later. But you can basically start to pull out this information. So you can detect when an endpoint is being compromised. So for example, here you can start to see things like this is actually W script, and W scripts communicated out to the internet and the URL. Now, in I think 99% of every normal environment, there's absolutely no reason for W script to go out onto the internet. There's no reason. Why would W script communicate to the internet? So when you're looking for attacks or compromises, this is a key indicator. And this is something that you won't see with the traditional endpoint solutions. So if you could raise this event and actually report it back into your SOC, you can actually start to build things more interesting. Same thing here. So we start, here's Excel doing the network operation to an IP address, and it's something called members.wshade.com.au, and then if you look at the URL, it's got some funny numbers and then funny numbers and .exe. Again, so why would Excel be downloading something like that? And if you start to get that information, if you start to pull that information into real time, you can start to see effectively which endpoints are being compromised and from where which delivery mechanism is being brought in. So this gets to threat hunting. I think threat hunting is going to be the new keyword of the year. Everybody's talking about it. The reality is that you're basically like this guy, sitting on a shitload of data, speaking my language, and you're looking with a magnifying for something that's interesting. But you feel like this, and this is what you actually happen. It's a painful, long, arduous task. You're sitting and sifting through tons of data, right? And you get really bored really fast. So in practice, threat hunting is an analyst versus an adversary. Okay? It's essentially intelligence. Right? You need to have somebody who understands things, knows what he's looking for, and understands how an adversary thinks or how an adversary acts. It's about being creative and adaptive, because you might think that you know things, but these guys probably know more. Or they found ways of doing things you never even thought about. So you need to be creative. You need to actually think like they think, so to speak. And you need to change your ways quickly. You're not looking for indicators. And that's the key thing. Is if you look at everything that we've been doing over the past few years in this domain, in terms of incident response, we've always been talking about indicators. But I'm going to show you some data where you can talk about indicators all day. You would have missed a piece of ransomware because all the indicators pointed to green lines. Deep analysis of potential compromised resources. When you think you see something, you have to go into and analyze everything that's available for that incident. So you're talking about looking at every firewall log, you're talking about looking at every proxy log, you're talking about looking at every event log from the machine, you're talking about looking at anything suspicious on machines that are connected to or not connected to the machine, that have been connected to that machine. And the important part is, as an analyst, it's about understanding, defining normal. Okay, what is normal in the environment? What is the standard approach? What are the normal network patterns? What are the normal network traffic? What's the normal time a user connects to his machine? Which users connect to the machine? Do you allow multiple users to connect to one machine? These are the types of things that you're going to look for. But Napoleon once said, war is 90% information. And that's what we're doing. Today, that's what, if you think about incident response, you've got information and you need to find something in that information. Right? So these are some of the things that you might have. You have firewall logs. You're looking for unusual IP addresses, countries, businesses, proxy logs, unusual traffic. You know, why do you have port 22 traffic coming out of your environment? Bytes in equal to bytes out. How many of you look for this in your firewall logs or in your proxy logs on a network connection? If you have equal bytes in to bytes out, it's a very unusual traffic pattern. Because that means you're sending and receiving the same amount of information. Right? Dynamic DNS. Dynamic DNS is a favorite thing of attackers nowadays. How many of you know how many dynamic DNS addresses or domain names there are today? There's like close to 4,500 right now. Different DNS subgroup domains. Unique user strings. So you're going to be looking for things like, def to America, things like that. I mean, anything that's just not supposed to be in a packet. Windows logs. So log on attempts. See how many attempts to log on happened when a user was added to network privilege. That's my favorite one, is looking for net user commands. Because first thing, once you get a compromised host, as an adversary, the first thing you do is going to add a local user and put them in the admin box. We had a case where we started to see manipulation of the credentials database. It's very interesting. So we started to see manipulation of the credentials database. Then we started to see the use of mimikatz. So, okay, somebody's trying to hack credentials. What we eventually found out is that, in fact, it was an internal person, it was actually a group of internal people, that were trying to get managers' accounts because they were logging into the manager's machines and deploying a hacking kit to basically monitor the microphone and monitor the video camera, so that they could snoop in on meetings, secret meetings. Antivirus logs. That's always interesting. You get all the antivirus reports. Then you've got the new generation of endpoint detection solutions, right? Detection and response. Those are all reporting indicators. They might put up forensics logs. They might put up memory dumps. But the key thing is, basically, everything on this goes into a SIM. It's the only way to do it. I mean, you can sit there and pull everything together, but if you don't have a SIM, you're not going to get very far. If you've ever played with a SIM, if you've actually followed me on Twitter the past 2 weeks, I've been going, God damn, I mean, QRadar, what the hell? I'm trying to do some reporting on some of this stuff in QRadar, to build some of the QRadar is not an endpoint SIM solution, okay? They do not understand the endpoint. And they have absolutely no feel for the endpoint. So we're trying to port the data that we're generating into QRadar, and it's a nightmare. It's just a nightmare. And I think it's fabulous to do it too. So this is half my day, I'd say, when I'm doing incident response. I sit there and I'm like, oh God, not again. It's like, what is this, all this junk? And I mean, you're sifting through lots and lots of data, right? So there has to be a better way to do this. That's my conclusion. I mean, we're pulling all of this information and we can add even more important information, but there has to be a better way to do it. And this is where I get back to my file events and some of the stuff I was talking about earlier of understanding how applications work. Because then you can start to build behavioral analysis. So you can start to build logic. You can do if A plus B, then C or D or E, but not X, Y, Z. You can declare certain patterns. Right? So this basically, if I were to convert this into something more meaningful, so if the user opens an email, double click the PDF inside that email, it launches Acrobat, and then the next step is if I see command prompt running, or if I see a DLL that's not normally loaded by Acrobat, I have almost certainly a malicious state. Then, if I start to see manipulations, other types of manipulations like touching the data, adding users to the admin accounts, then I definitely have an endpoint that's risky, or an endpoint that's compromised. So, I'm going to drill down a little bit into that. So here, basically, how do we build this behavior sheet? So when you open a file in Outlook, it actually creates a temporary file. So it writes that file to a new location, creates an intent, then writes it to another, then copies it, and it opens it launches a process to open the file. So one of the things that we start to think about is, well, let's tag this file, right? So what we know and understand that this file has been saved from an email. It's important because the user might actually save the email file, the attachment, and open it later. So you need to be able to track that file over time. So we see a process opening the tagged file. We can raise this as an event, attachment opened. Okay? So we know that the user is in a state where he's opened an attachment that's come off an email. From there, we see Office opening the macro subsystem. So there's a number of calls that are made, a number of DLLs that are loaded. So if we track that, we know that we've got an active attachment opened. Then, typical compromise, you're either going to see a file write, or the spawning of a network connection, or even the spawning of a command shell with an echo or a bat file. But usually, I'd say 90% of the times that we've seen this, it's always either a network operation first and then a write file, or just directly a write file. So depending on the type of attack that's in the attachment, they've either got the binary, they've got a stub binary inside the file, so they'll write out the binary, or they go connect to the network and download the binary. We then see that file moved into local app data. Why do they do that? Because they know that any system, even locked down, local app data you're allowed to run stuff in. So we're in a state of risk. We've got suspicious activity going on. So then that binary either executes, or that file either executes, or it's running the command shell. Lately, I think it's been mostly command shells and scripts that have been running. So we've got an elevated risk. From that point, if we have an intelligent agent, we can start to track everything that's going on and generate more data. Why is this important? Because if you remember when I was talking to you about threat hunting, there's a lot of data. If we start to add all the endpoint data that we can generate, it's going to be massive amounts of data. So we want to keep the data to a minimal until we're in a state where it becomes important. We also want to be able to say, well, I'm at this state. Let's notify the operators. Let's notify the analysts. Let's trigger the alarm. So if I have all this data back into my SOC, I send all this data back into my SOC, I can start to build dashboards that trigger alarms and say, we think this endpoint's been compromised. So now, hopefully, this won't be too small. So I've knocked it down to 2 because, but if you're interested in seeing some of this, I can show you. There's one really interesting one that we did. Well, one of our customers has a lot of Chinese contractors, and they allow them to deploy a tool from Tencent that does dynamic translation, or it's like a dictionary tool and a keyboard tool. It's like, fine. But then you see it loading into Office. It loads, I think, 5, 6 DLLs, 1 executable, and then you see words start communicating out to IP addresses in China, which is really interesting. So our core origin, Digital Guardian, is data loss prevention. So when you see that, you're like thinking, okay, I'm sitting here, there's a guy going out to, there's all these word processes, basically communicating back and forth between your office and China, a server in China. And it's like, so we discussed it, and yeah, it's a tool, it's a dictionary and a keyboard. So basically what you're telling me is that every time that Chinese user needs to find out what the English word is for the report that he's writing, he's basically typing that word or typing that phrase into this tool or highlighting it in Office, and it's being sent to China. You can imagine what the next response was. I've got this one I will show you, Dridex. So the alerts that the things that we picked up, Dridex. I won't show you this one, and I'll show you ransomware. The ransomware was actually really interesting. So it was one of our customers, and they sent me an email with a really interesting ransom. So this is Dridex. So hopefully you can see that person. So down here, So this is where, basically, when I talked about Outlook, when you open attachment, this is where we've actually generated a file copy event, and we see the name of the attachment. We have more information as well, like the file path and things like that. Then we see Excel making a copy of it. So basically what happens is Outlook does that copy in one location, then Excel puts it into its own temporary environment. And this DLL load is when we start to see the macro subsystem being pulled out, okay? So then, this is the fun part. We see Excel doing network connections to an IP address on the internet, port 80. Why port 80? Because most firewalls and proxies let port 80 go through. They don't know it's Excel. And this is the URL, this is the domain name, and then we put a server. Up here, it's actually a few little R's. That's the initial connection. Yeah, so here's the actual URL, because he does the initial connection to open the connection, TCP connection, when he's actually downloading the file. Once he's downloaded the file, he writes it to the disk. You see here he's writing it. He's actually writing it in the local app data. So we've got multiple write events. Now, if the agent's intelligent enough, it can differentiate between a binary and a non-binary file. Then it gets renamed and gets kicked off by Excel. So here we would have parent information. We can pull out SHAs and U5s, whatever you need. Then we see this basically going out. This one was interesting. It was actually doing TCP connections to this botnet on 8448. And I was surprised that was actually going through on some proxies. But then I realized why. It's just because some people just allow anything over 8,000 on their proxies and firewalls. Because they know that a lot of websites do that. We use weird ports. So this is a ransomware attack from April. So there's a lot more detail in here. So this is the thing. It's like what I'm saying is that you can get as much detail as you want if you're doing the right listening on the endpoint. So here, basically, this ransomware was a zip file with a JavaScript attachment. So here we see the original. Well, I don't have the actual opening of the zip file, but this is where it starts with the W script. So here we see the command line. It's a simple command line because the user double-clicked on the file and zip. But we have the path, so we know what the original file was. We don't have to go trying to figure it out in our forensics. We have that file. And if you notice the file name, it ends. So the actual phishing attack was actually quite cleverly done. It was a notice to appear in court. And when you receive a notice to appear in court, the first thing you do is you open it because, you could have to go to court. So it says notice to appear, it's got a serial number, and it says .js. Most users don't have the file extension visible on their Explorer. So when they open this, they see .doc. Oh, my security guys tell me I'm allowed to open .doc files. It's okay, because we have protection on .doc files. So then WScript actually starts to read some stuff. Then does a connection out to the internet. So we start to capture IP addresses again, and actually downloads. So here we have, let's go look at this URL. So this URL is actually quite complicated. Yes. So it's a really long URL. Basically, this ransomware was hiding an ad server, and they managed to compromise the ad server, and there was a whole bunch of registration information and everything in it. So then we see it basically loading some DLLs, doing some more network. Then it flags the first loader. So this one is this first hook into the system. Basically, and I ran this multiple times. Each time it was a different version. Same name, but the MD5 changed every time. It's essentially just a downloader. And so he does one of those, then he does another network connection, and he launches a second downloader. And the second downloader is actually the one that's going to start doing the malicious stuff. So then we see it launching a CMD. Now, if you're smart and your agent's good, you can capture the actual command line. So here I actually see that he's adding a registry entry in the runs, and he's calling it encrypted, and he's got a text file. So basically, that's where he's going to have, when you reboot, you're going to get the message. So then he adds some .crypted entry into the classes, so that his extension .crypted gets recognized as a file type and not opened while it opens the notepad. So then he adds some information about decrypting, encrypted. There's the registry. So I'm actually tracking a lot of detail. So we saw the command lines, and then we actually see reg activating. So then we have file writes. He's gone out to. So here's the interesting thing. He goes out and downloads sdelete from livesystemterminals.com. Okay. How many of you think that would be flagged on anybody's firewall or anybody's next gen network device? It says delete. It's green. You know, Cylance, you know, they could say they have all this fucking fancy technology, they still send it to Vitalik, it's green. It says delete. It's Microsoft. Then he starts his batch file. And this one was really good. He has a batch file that basically does a for command recursively on every drive letter imaginable from B to Z. Okay? And he's looking for typical Office file types, well, you know, business file types. And then he does that as a for loop, and he pipes it into a find string to actually get rid of anything that's in Win boot system and stuff like that. So he's compiling a list of files that he wants to encrypt. He then calls another application that he's downloaded, A0.exe, and I'll show you the actual command line for that one in a minute. So there he starts to do, we'll have 0 minutes. So let me go down to A0. So we have 1. Okay, this is a, oops. Ah, crap. Self-crash. Don't teach me to use Excel. Instead. This is what I mean by so, A0 does controls the half of the internet. So this one is A9. So that's A9 is just delete, the command line. He's basically doing A9 minus A9 is Q, and then the name of the file, the original file. After we encrypt it. Yeah. So this is the command line that he's using. Okay, so he's copied it into app data, so he's A0.exe, next parameter is A, then minus mx0, then minus meh, then minus p, a whole funny string, the name of the file, encrypted, and then the file. Does anybody know what that command line is? When I saw this, it jumped straight to me. No. It's a really simple tool.
Archiving?
It's 7-zip. We basically repackaged 7-zip, put in a few modifications to trick the MD5, and it did his archiving into well, he encrypted the archiving process. But minus P, guess what? Go away, I got your password. So that's the kind of things that you can do if you have an intelligent endpoint feeding your data into your software. That's it.
Thank you very much.